Hello everybody and welcome to another mathematics video. And for today's video we're looking at a very beautiful topic. But before I tell you the name of that topic, let me first take you on an adventure. So let's just say you're one of the best scientists in the world. And as one of the best scientists in the world, you're building a rocket to take you from Guyana to the moon. So before you can actually go on this journey, you need a few details. You have to record some data so that you can have all the information that you need to have a safe journey. So one of the things that you want to record the distance from Guyana to the moon. So as one of the best scientists, you went back into your lab and you built a very long measuring tape that can measure from Earth to the moon. So you're using this measuring tape and you're measuring, and then you finally reach the distance from Earth to the moon. And you're about to record the measurement from the measuring tape. You're writing on the measuring tape, the distance is in meters. So you're writing on the measuring tape, you're writing. You filled up one page, you went ahead and filled up another page because the digits are not stopping. And you fill until you're tired. Now, for today's topic, we will be tackling something that the scientists discovered, or something that the scientists invented to make it easier to write these very long and these very large numbers. Something very simple. So instead of filling pages and pages of digits, you can use this method to summarize the number and make it easier to write. So for today's topic, we're looking at scientific notation. So scientific notation is a way of writing very large numbers, like the measurement from Guyana to the moon that we were trying to write as a scientist, or very small numbers. Let's say you want to measure the length of a bacteria or something. That would be a very small, it would be 0.00000 something. So we write these very large and very small numbers using powers of 10. Now it is written in the form a multiplied by 10 raised to the n power. Now this a multiplied by 10 raised to the n power is just the general form of how the scientific notation will look. Now a would be a number that is greater than 1 but less than 10. A cannot exceed 10 nor can it be smaller than 1. And n would be an integer, and it's positive for a large number, greater than 1, and negative for small numbers, less than 1. We'll look at that more in detail when we look at a few examples. So the general form for a scientific notation, of writing a number in scientific notation, it's a, and a is a number greater than 1 but less than 10, multiplied by 10. 10 will always be 10, raised to a certain power, which is represented by n. Now, n would be positive depending on the direction that we move, and negative depending on the direction. So let's look at some examples. So the first example, we want to express 45,000 in scientific notation. So the first thing, 45,000. 45,000 is a number greater than 1. So of course, whatever power we're raising 10 to, it has to be positive because 45,000 is greater than 1. So we have 45,000 and we want to write that in scientific notation. Now there's another word that we use for scientific notation, which is standard form. Now both scientific notation and standard form, they mean the same thing. These words are used interchangeably. So sometimes in your exam, you may see write your number in standard form, or it may be write your number in scientific notation. Just remember that they both mean the same thing. So let's look at 45,000. So the first thing we want to do with this 45,000, we want to move the decimal point and put it between the first two digits greater than 1 but less than 10. Or we can say the first two non-zero digits. Alright, so we know the decimal point is here, it's at the end of the number. So we move it 1, 2, 3, 4. So 45,000 will now become 4.5. Now we're always multiplying by 10. Now this 10 has to be raised to a certain power. And the power will be depending on the amount of times we move the decimal point. So we see we move the point 1, 2, 3, 4 times. So this will be 10 to the 4th power. Now remember earlier I said the 45,000 is greater than 1, so the power has to be positive. Now, there's another way you can remember whether the power will be positive or negative, as you will see in the future examples. If we are moving the point into that direction, the power will be positive. If you're going in the other direction, then the power will be negative. Or we can look at the original number. If the original number is greater than 1, then the power will be positive. If it's less than 1, then the power will be negative. So let's look at another example. So let's say we have express 0.00032 in scientific notation. So we have 0.00032. And of course, we see this number is less than 1. So we know that our power will be a negative. So we move this point and we put it between the first two non-zero digit or the first two digit greater than 1 but less than 10. However you want to remember it, it's up to you. Either the first two non-zero digit or the first two digit greater than 1 but less than 10. So we move 2, 3, 4. So this will become 3.2 multiplied by 10. We're always multiplying by 10. Raised to the certain power depending on how many times we move the decimal point. So we see we moved it 1, 2, 3, 4. So this will be 10 raised to the negative 4 power. So of course, if the number is less than 1, then the power will be negative. And in the previous example, we saw that 5,000 was greater than 1, so the power was positive. And in this example, we see 0.00032 is less than 1, so the power was negative. So let's look at a few more examples to cement this concept. So let's say we want to write 6,300,000 in scientific notation. So this will be 6,300,000. So we know the point is here. So we jump 1, 2, 3, 4, 5, 6. So this will be 6.3 multiplied by 10 raised to the 1, 2, 3, 4, 5, 6 raised to the 6th power. So let's look at these two last examples to cement this concept once and for all. So we have 987,000 and we want to write that in standard form. Remember, it's the same thing. So we have 987,000. So we see the point is here. So we jump in 1, 2, 3, 4, 5. So this will become 9.87 multiplied by 10. Now we're not including these zeros. It doesn't make sense for us to include the zeros and write 9.87000. These zeros, they have no value. So you can just leave it out. So this is 9.87 multiplied by 10 raised to the, we saw that we move 1, 2, 3, 4, 5 raised to the 5th power because 987,000 is obviously greater than 1. And the last example, we have 0.0000762. We want to write this in standard form. So we see we move. Obviously, we see this number is less than 1, so we see our power will already be negative. So we jump 1, 2, 3, 4, 5. Now, there's a reason why some person may jump and put in an extra step here and say 76.2 multiplied by 10 and so on. But remember, this number here has to be greater than 1 but less than 10. So it cannot be 76.2. 76 is obviously greater than 10. The decimal point has to go between 7 and 6. This would be 7.62 multiplied by 10 raised to the, we saw that we move 1, 2, 3, 4, 5 times. This would be negative 5 power. And that is how we write numbers in scientific notation or standard form. And with that, it has brought us to the end of this video. And I trust that you now have a firm understanding of writing numbers in standard form or in scientific notation. I'll see you in the next video.